Yes, we will go with another problem. Calculate the Thevenin equivalent circuit across AB. Calculate the Thevenin equivalent circuit across AB. Okay. So no load is given. Load current we need not calculate. Only VThevenin, RThevenin value. Okay. Only VThevenin, RThevenin value we have to calculate. In previous problems, we came across DC voltage. Now this sinusoidal symbol is there. This is AC type of voltage. Sinusoidal symbol is there. AC type of voltage. So this complete circuit, we have to make it a single voltage and single resistance. This is the Thevenin equivalent circuit. A, B are the points. Okay. In the circuit, we have only one voltage source. In the circuit only, we have one voltage source. So current flows in the loop 1. This is the closed loop. So current flows in this loop 1. If we are able to calculate the voltage in this 3 and J4, we can calculate the VThevenin value. So this current into this 3 and J4 is the parallel path across which we are calculating VThevenin value. Okay. And here you can see when voltage is there, this is rough calculation. When voltage is there, R1, R2 is there. How we calculate voltage across R2? Total voltage into R2 divided by R1 plus R2. Okay. Total voltage into R2 by R1 plus R2. Same formula we have to apply. Same method we have to apply here also. This is the total voltage. We want the voltage across 3 plus J4. These two are in series. So I will take 3 plus J4. So Vs is the total voltage. 3 plus J4 divided by, here R1 value is 5. So 5 plus 3 plus J4. So this portion, this inductor will not have any effect because here there is no closed path, no current is flowing in this inductor J5. J5 inductor, there is no current flowing. So it will not come in the calculation of voltage. If current is flowing, then that voltage also we have to calculate for getting overall across AB points. Okay, here no current, so no voltage is 0. We can neglect this. And now as per our calculation, so this Vs value is 10. Numerator becomes 3 plus J4. Denominator 5 plus 3 plus J4, which is 8 plus J4. Okay, this 5 is R1 value 5. R1 value. R2 value 3 plus J4 because they are in series. Next, how to simplify this? How to simplify this VThevenin value? So if A plus JB is there, this is of rectangular form. Okay. When we convert it into polar coordinates, we will have magnitude and phase angle. You know how to calculate magnitude for A plus JB. This is square root of A square plus B square, which is the magnitude of A plus JB. Phase angle is plus tan inverse B by A, plus tan inverse imaginary part by real part. This is the phase angle. So this magnitude and phase angle put together is called polar coordinates. So rectangle is A plus JB format and polar coordinates is magnitude and phase angle. Now in the numerator we have 3 plus J4, 3 plus J4. When we calculate the rectangle to polar conversion using calculator, rectangle to polar conversion, 3 plus J4 value is 5 angle 53. Similarly, denominator we have 8 plus J4. So this also rectangle to polar conversion, 8 plus J4. When we convert, it becomes 8.9 angle 26.56. This is in numerator. This is in denominator. I am writing as it is. VThevenin calculation 10 into, okay, this 10 into 3 plus J4 means polar coordinates 5 angle 53. 8 plus J4 means polar coordinates 8.9 angle 26.56. Now further simplification, this magnitude as it is, we can operate 10 into 5 numerator, denominator is 5.944. Phase angle denominator, if we take it to numerator, it becomes minus. So 53 is numerator phase angle. Denominator phase angle comes to numerator means minus 26.56. So we can cancel here as we like 50 divided by 8.94. 50 divided by 8.94, 5.58. And here this becomes 25.5. This is VThevenin value. VThevenin completed. Now coming to RThevenin calculation. RThevenin calculation. This is our original circuit. We have to calculate RThevenin across AB. Make all the sources inactive. Voltage source means short circuit. Current source means open circuit. Okay. So for the original circuit, we are doing like this. We have voltage source, so we have done short circuit here. Remaining circuit, everything is as it is. Now calculate RThevenin means these two are in series and that is in parallel with 5. Okay, that resultant is in series with J5. So here you can see 3 plus J4, okay, which is parallel with this 5. After calculation of that, it becomes series with this J plus J5, okay. When we do the parallel, this two parallel, R1 into R2 divided by R1 plus R2 we have done, okay. On simplification, this becomes 15 plus J20, 8 plus J4. This is plus J5 second term. When we make LCM, denominator 8 plus J4, numerator will become 8 into 5 is 40J and 4 into 5 is 20. J square becomes minus 1. J square becomes minus 1. Okay. So when we simplify, 15 minus 20 becomes minus 5. 40J, 20J becomes 60J. Denominator 8 plus J4 as it is. Now calculate magnitude, square root of A square plus B square for numerator. Okay, phase angle tan inverse plus tan inverse imaginary by real. Denominator also square root of A square plus B square. Then angle tan inverse B by A. And after that, when we simplify, it becomes 6.73 and angle is minus 111.56. This is polar coordinates. Or you do rationalization for the rectangular coordinates and calculate, it becomes 2.5 plus J 6.25. Okay, from the rectangle itself, you can simplify and get this answer. Otherwise, in the polar coordinates, you can simplify and get this answer. This is about the third problem in Thevenin's theorem, where we had AC voltage and only one voltage source is present and completely inductor, okay, resistor, series, parallel paths we came across and find the answer.